Alright, now we're starting section 4.5. 4.5 is concerned with a type of problem generally called mixture problems. With these mixture problems, it can be a little tricky to try to set them up because unlike with uniform motion problems where you can generally just go to the distance equals rate times time formula, you're not given a formula on these. You kind of have to figure out what formula is appropriate. And so reading through a question like this, we have a class of school children and their adult chaperones took a field trip to watch a play. The total cost of admission was a certain amount for 38 tickets. We know that each child paid a certain amount and each adult paid a certain amount, and we're trying to figure out how many adults and how many children went on the trip. So, in order to set this up, I have to kind of think about what equation can kind of relate these things. So noticing this $6 each, this is a rate. This is $6 per child. Whenever you see a rate in a problem like this, this kind of tells you an implied sort of an implied formula. Because if I was to take this $6 per child and multiply it by the number of children, well, the number of children and the number of children here, or that unit and that unit would cancel out. We'd still have the number here, we wouldn't be counting children anymore, and we would end up with a dollar amount. This is actually the equation that I'd be using here. I'd say that the total dollars, the total amount of money paid for the children is $6 per child times the number of children. Now, in retrospect, that seems kind of obvious, but we can also do the same thing for adults. $8 per adult times the number of adults. But once we have an equation like that, we can set up our chart. So we can say, I'm going to go ahead and say the rate. Here we have the number of people. And this, when I multiply those together, I get a dollar amount. So total dollar. Alright, so we have two groups. We have children and we have adults. And I'm setting up the chart, again, just to kind of keep track of all the different variables and keep everything straight. The total cost of admission was $226. So I'm reading through and trying to figure out if I can put any values in here. The total cost of admission is $226. That is, well, that doesn't fit in this chart. But it might be helpful to have a third row on here to talk about totals. So the total cost of admission here, we're talking about a dollar value, so that's how I know I'm over in the third column. The total cost should be $226 here. The total is for 35 tickets. Again, this is the number of tickets, or the number of people, the number of tickets. That's kind of the same column here, but it's overall for everyone. It's not for the children or the adults. So I'm going to go ahead and put it down here in the total column. All right. Let's see. Children paid $6 each. Well, okay, so that's that's their rate. And adults paid $8 each, that's their rate. And those are all the numbers from this problem. So now I need to introduce some variables, and that might make sense, especially since we're asking how many adults and how many children are on the trip. I'm going to go ahead and make those my variables. The number of children is x, the number of adults is y. And since I have two of the three parts of this equation, I can then say the total amount of money spent on children is 6x, the total amount of money spent on adults is 8y. Okay, so I filled out my chart, and the reason it's nice having it written like this is because I know that if I take the number of children and add them to the number of adults, I should get the total number of people, the total number of tickets in general. So this tells me x plus y equals 35. That's one of my equations. And my other equation is right here. The total dollar value spent on children plus the total dollar value spent on adults should be the total dollar value spent in general. So 6x plus 8y equals 226. So those are my two equations. You'll notice that this equation right here, this one right here is referring to just the tickets, or the people. So it's taking the number of tickets plus the number of tickets gives you a number of tickets. This equation right here is all dollar values. 6x is the amount of money spent on children, 8y is the amount of money spent on adults, 226 is the amount of money spent on in general. And whenever you're setting up an equation, the units always need to work out like that. You can never add a number of people to a number of dollars. You know, it just doesn't make sense to add those two things together. So just don't do it, essentially. All right, so we have our two equations, and we need to solve this system of equations, because x and y, the number of children and the number of adults, those are the things I'm after. When looking at this, I think I'm inclined to use the elimination method, since they're both in standard form. But if I just add them together as it stands, the numbers aren't going to cancel out. So what I'm going to do is I'm going to say I'm going to make this x. I want to make this into a negative 6x, so that when I add it to the 6x here, they cancel each other out. So what I'm going to do is I'm going to multiply the first equation by negative 6, because that'll make this into a negative 6x. But I can't stop there. I have to do it to the entire first equation. So I get negative 6x plus negative 6y equals, well, 35 times negative 6 gives me 210. But that's negative, so I should include that. So my first equation becomes negative 6x plus negative 6y equals negative 210. I didn't modify my second equation, so I'll just copy it down. And now I can add these two equations vertically. It's important when I'm adding them vertically that everything, that they're both in standard form. Or at the very least that my equal signs line up. That's the bare minimum that needs to happen there. So adding these, the reason I'm doing it is because we get cancellation here. 0x, which is 0, that part goes away. I get 2y, the negative 6y, plus the 8y gives me 2y there. And over here, when I do that subtraction, I get 16. So 2y equals 16, or y equals 8, when I divide both sides by, what, 2. So y equals 8. Let's find x. I'm going to go ahead and use that first equation because it looks pretty easy. X plus y equals 35. That'd be easy to substitute in 8 for y. X plus 8 equals 35. Subtract 8 from both sides. I get x equals 27. And we have found the values of x and y. Let's go back up here to remind ourselves what x and y stand for. X is the number of children. Y is the number of adults. So I'll write that down here. This would be 27 children and 8 adults. Before I move on, I'm just going to quickly verify that everything works out. This should be a total of 35 children, or 35 people rather. So let's verify 27 plus 8, that is 35. Also, we know that the children's tickets sell for $6 each, and the adult tickets sell for $8 each. So if I type that in, I get a total of $226 spent there. I'm just evaluating each of these equations. I checked that one, and I checked that one. So I've now satisfied that this is the answer to this question.